I'm Mr. McBrien, and this is SCH4U, Functional Groups, Part 1. So today what we'd like to do is talk about organic compounds that contain oxygen. We'll cover a number of different types, how to name them, a little bit about their properties. We're reserving a lot of that for a later discussion. And we're also going to talk a little bit about just kind of a rule of thumb for the way that alcohols and some other compounds are put together. Okay, so by the end of the period, you should be able to name oxygen-containing organics, draw them from their names, and you should be able to talk a little bit about the properties of these things. Okay. So oxygen-carbon bonds are not like some of the other ones we've seen so far. And the reason for this is that oxygen has a higher electronegativity than carbon. And as we talked about in the previous structure and bonding unit, electrons then are pulled to the oxygen atom from the carbon, creating what's called a polar bond. And this polarity then makes the compounds that contain oxygen more polar. And one of the aspects of that then is that they have better water solubility. Now, compounds that contain a hydroxyl group are called alcohols. And here are some examples. Here's ethanol. Here's 2-propanol. Really, all we're doing is replacing a hydrogen with an OH group. If we want to name these, we're going to name them rather than a prefix. We're going to use the suffix OL to denote that functionality. And of course, other than the absolute smallest of the alcohols, we're going to need to tell the observer which carbon they're attached to. So if we have this compound, 2, 4, 6, 8, this is octane, but on the 4th carbon we have an alcohol group. So this would be 4-octanol. And an alternate name could be octan 4-ol. We'll typically use the first name, 4-octanol, for this. Okay, so here's a little bit larger example then. We have 2, 4, 6, so that's based on hexane. So we have 2 is the carbon for the hydroxyl group. So this will be 4-chloro-2-hexanol. Oh, I forgot the methyl group. One point off from Mr. McBrien there. So 4-chloro-4-methyl-2-hexanol. Okay, so feel free to pause the movie at this stage and do some naming of alcohols on the worksheet, or you can continue to see some of the other oxygen-containing compounds. So oxygen, because it has 2 bonds that it can form, in alcohols, of course, one of those bonds is used up by hydrogen. But if we form a double bond with carbon, then we don't need that hydrogen. So this carbonyl can be at the end of a molecule, and when that occurs, we call this an aldehyde. We'll give the compound, instead of an ol, we'll give it the suffix al. And we won't need a number, because aldehydes by definition have the carbonyl at the end of the molecule. We don't need a number for it. So in this case, a 7-member chain, we have heptanal. So let's do an example here. 2, 4, 6. So this is once again hexane, but it's hexanal because it's an aldehyde. And then we have 1, 2, 3, 4. So it's 4-fluorohexanal. And again, automatically then, the aldehyde functionality is given carbon number 1. Now, it might occur to you, what if the carbonyl isn't at the end of the compound? Well, these kinds of compounds have such a different functionality, we in fact call them something different. When the carbonyl is not at the end, we call this compound a ketone. So if there's a carbon, a carbonyl, and then another carbon, we call this a ketone. And no great shock, we're going to give the compound the suffix -one to tell the observer that it's a ketone. So in this case, we have 2, 4, 6. This would be hexanone, but the carbonyl's on the third carbon, so this would be 3-hexanone. In this case, 2, 4, this would be 2-butanone, but notice that there is no other option, so we don't need the number here. So it's not 2-butanone, it's just butanone. So for this example then, we have 2, 4, 6, 8, 9, so this would be nonane. We have our ketone, makes it nonanone. We have then, this is on the third, so this would be 3-nonanone. 5-amino, 3-nonanone. 5-amino, 3-nonanone. Hey, I got it right. Good stuff. Okay. Now, something special happens if we attach a hydroxyl group to the end of an aldehyde. So when we put the hydroxy group next to the carbonyl, the alcohol proton, which is normally very firmly attached to the alcohol, can actually move off of it. It can dissociate. And so this has led this class of compounds to be called carboxylic acids. Now, it's important for us to note that these are weak acids. In normal situations, even in aqueous solution, they exist primarily in their neutral form. But they do some very special things because of this proton being mobile. When we want to name these carboxylic acids, we change the suffix to oic acid. Again, there's no need to number these ones because, like with aldehydes, by definition, the acid group must be at the end. So here's an example for us, a 10-member chain, decanoic acid. So let's try an example. 2, 4, 6, 8. 8 carbons, so this would be octanoic acid. And again, this carbon is automatically designated number 1. So this would be 7-bromo octanoic acid. Now, like with so many of these compounds, there are some exceptions, some common names that have become in the accepted nomenclature, and we have to know these. We already talked about benzoic acid. This is formic acid. And here we have cyclohexane carboxylic acid. Bit of a mouthful there. So these don't follow precisely the rules that we just covered. You can, of course, name things as derivatives of these common names as necessary. Now, a little bit of a departure. Now that we've talked about alcohols, we can talk about the idea of classing certain compounds according to what's attached to the carbon to which they're attached. This is better. The reason why we waited so long to talk about this, it's better to talk about this in terms of specific examples. So here are three kinds of alcohols. One here where we have the hydroxy group attached to a carbon which has two hydrogens and some kind of carbon substituent. In this case, there's only one hydrogen and two alkyl chains. And finally, the case where the carbon has no hydrogens and only has these alkyl chains attached. Now, the reactivity of the carbon involved changes with these numbers of protons. And for this reason, we've seen fit to designate specific types to these. So we talk about alcohols where the alcohol is attached to a carbon that has two hydrogens. We call those primary alcohols. Secondary alcohols have two chains attached, and tertiary alcohols have three. So it's important for you to remember those designations as we move forward. All right, so for tonight then, please read through the class note and make your way through the worksheet, Functional Groups 1. Thanks very much. Have a great night.